Question 8. Functions f and g are defined as follows. Fx is equal to x square minus 1 for x is less than 0. This is the domain of the function fx. X is less than 0. Gx is another function, that is 1 over 2x plus 1 for x is less than negative 1 over 2. This is the domain of x is less than negative 1 over 2. This is the domain of gx. Solve the equation f gx is equal to 3. Solve means we have to find the value of x from this equation. This is the composition of two functions f and g. So f gx is equal to 3. So we can write it as f f within bracket gx is equal to 3. Now we will put here the value of gx. Gx function is 1 over 2x plus 1. So we can write f in place of gx. We will put here the value of gx. So this becomes f 1 over 2x plus 1 is equal to 3. Now we will compare it with the function fx. Fx is equal to x square minus 1. We put here the value of x is equal to 1 over 2x plus 1. Then it becomes x square means 1 over x is now x is 1 over 2x plus 1. We will take this as x in original function fx. This becomes 1 over 2x plus 1 square minus 1 is equal to 3. So now we can write it as 1 over 2x plus 1 square is equal to 3 minus 1 will move to the right. This becomes 4. Square is here. Now we can write it as 2x plus 1 taking the reciprocal 1 over 2x plus 1. This becomes taking reciprocal on each side is equal to 1 over 4. Taking square root each side, we get 2x plus 1 is equal to plus minus the square root of 1 over 4 is 1 over 2. So we get from here 2x plus 1 is equal to 1 over 2, or 2x plus 1 is equal to negative 1 over 2. 2x is equal to 1 over 2 minus 1, negative 1 over 2. From here x is equal to negative 1 over 4. This is the value of x. Now another value of x from this equation 2x plus 2x is equal to negative 1 over 2 minus 1. 2x is equal to negative 3 over 2, and x is equal to negative 3 over 4. These are two values of x. This is the solution. But now we justify which value is valid, which is not valid. Or look at this. This value x is equal to negative 1 over 4. This is not the solution. This is not applicable. Only the solution is minus 3 over 4, because the value of x depends upon the domain of the function. The domain of the function gx is x is less than negative 1 over 2. So Accordingly, the domain we will accept only the value of x is equal to negative 3 over 4 because the domain is x is less than negative 1 over 2. So the only answer is x is equal to negative 3 over 2. Move to the next part of this question. Now we have to find Fg inverse composition. We have to find the inverse of the composition of Fg function. So same method as we have done already the questions of inverse. So first we put Fg is equal to y. We have Fg function. Fg function in part 1, that is 1 over 2x square, 1 over 2x plus 1 whole square minus 1. Fg function is, we have found already, Fgx is 1 over 2x plus 1 square minus 1. Now to find the inverse, first we put this Fgx is equal to y. Put Fgx is equal to, let this is y. So this becomes y is equal to 1 over, y is equal to 1 over 2x plus 1 square minus 1. We can rearrange it in this form: 1 over 2x plus 1 square is equal to y plus 1. Taking the reciprocal on each side, 2x plus 1 square is equal to 1 over 1 plus y. Taking square root each side, 2x plus 1 is equal to plus minus 1 over 1 plus y square root. 2x is equal to minus 1 plus minus 1 over 1 plus y square root. X will be minus 1 plus minus 1 over 1 plus y divided by 2. So we can write each term will be divided by 2. X, we can write it as x is equal to minus 1 over 2 plus minus 1 over 2, 1 over 1 plus y square root. So now from here we can say that inverse Fg inverse will be minus 1 over 2 plus minus 1 over 2. Now we will replace y by x, 1 over 1 plus x. This is the inverse function of Fg. Now we justify that either plus is here or minus is here. It depends upon the domain of the function. Since the domain of the function is x is less than negative 1 over 2, so we will accept only the negative value. So Fg inverse will be minus 1 over 2 minus 1 over 2 1 over 1 plus x whole under root. Now next question asks, this is question number 9. A geometric progression is such that the second term is equal to 24% of the sum to infinity. Find the possible values of the common ratio. This question is of geometric progression. 24%. The sum second term is equal to 24% of the sum to infinity. Find the possible values of a common ratio. The second term of geometric progression is, we will write A2. A2 means second term of geometric progression. A2 will be AR. This is the second term of GP. Or sum to infinity, sum of infinite terms will be equal to A over 1 minus R. Now it is given in the question that second term is equal to 24% of the sum to infinity. We will make our equation according to the given statement. Second term will be equal to 24% of mean multiply of sum to infinity. Now we will put the value of A2 and S infinity here. A2 is AR. 24% mean 24 over 100. Now S infinity is A over 1 minus R. Uh, now we can cancel out A from each side. A is cancel out from both sides. 24 over 100. After cancellation, it will become 6 over 25. So we get R is equal to 6 over 25 into 1 over 1 minus R. So this becomes R is equal to 6 over 25 into 1 minus R. Now cross multiplying, we get 25 R, 25, 25 R into 1 minus R is equal to 6. To simplify it, 25 R minus 25 R square is equal to 6. Rearranging it in standard form, we get 25 R square minus 25 R plus 6 is equal to 0. Now we use here the calculator, or otherwise we can also use the quadratic formula as well. But using calculator, here we can get the two values of R. R is equal to 3 over 5. This is a quadratic equation in R. We can use here the calculator. We get two values of R. R is equal to 3 over 2, or R is equal to 2 over 5. These are the two possible values of the common ratio. Now part B of this question is, another progression P has a first term A and the common difference D. Now here in this question the progression is arithmetic. An arithmetic progression P has first term is A and common difference is D. An arithmetic progression Q, uh, another progression AP, that is named as Q, has first term 2 into A plus 1 and common difference is D plus 1. There are two arithmetic progressions P and Q. First term and the common difference of both arithmetic progressions are given. Also, it is given that fifth term of P over 12th term of Q is equal to 1 over 3. From here, we get an equation in A and D, and also there is another ratio, sum of first 5 terms of P over sum of first 5 terms of Q. is equal to 2 over 3. So we get two equations, one equation from here, other equation from here. In the first case, we will use the nth term formula. In case second, we will use the uh, sum of n terms formula of AP. So we get two equations in A and D. Then we will solve those equations simultaneously. We will get the values of A and D. So first, we look this first ratio. First case, fifth term of P over 12th term of Q. The first term of P is A. Common difference is D. So the fifth term of P, we can write it as A plus 4D. This is the fifth term of P over 12th term of Q. That is the first term of Q is A 2 into A plus 1. So this becomes 12th term of Q will be A plus 11D. So A is 2 into A plus 1 plus 11 into D. D for Q is it is given D plus 1 is equal to 1 over 3. Now we will simplify it. Numerator remains the same or denominator become 2A plus 2 plus 11D plus 11 is equal to 1 over 3. Simplifying the denominator of the left hand side, A plus 4D remains the same. Adding the like terms, 2A 2A plus 2, 2A plus 11D plus 13 is equal to 1 over 3. Now we cross multiply here. So this becomes 2A plus 11D plus 13 by cross multiplying 3A plus 12D. So this becomes, after simplifying, we get 0 is equal to 3A plus 12D minus 2A minus 11D minus 13. So we get A plus D is equal to 13. Say this is equation number 1. Similarly, we will find we look this case number 2. Here the sum of first 5 terms of P over sum of first 5 terms of Q is given, that is 2 over Q. So now we use here the formula for sum of n terms, sum of first 5 terms of P, sum of first 5 terms of P, that is the formula for Sn will be n over 2, 2A plus n minus 1 into D. So this becomes, for the case second, for P, sum of 5 terms of P, 5 over 2, 5 over 2, 2A plus 4D using sum of n terms formula n over 2 2a within bracket 2a plus n minus 1 into d. So this will become the sum of first 5 terms of p. Similarly, sum of over sum of first 5 terms of q. The first term for q and common difference are given here. This is the first term of q and this is the common difference d plus 1. So we use here a and d. This becomes 5 over 2. 2a, a is 2, a is a plus 1. It is given 2 into 2 a plus 1 plus 4 into d plus 1. It is given 2 over 3 is equal to 2 over 3. Now we will simplify it and will make another equation in a and d like equation number 1. So we can cancel out these 5 over 2 from numerator and denominator. Further simplifying, we get 2a 2a plus 4d. This is the numerator. In the denominator, we simplify it. That becomes 4. That becomes 4 a plus 1 plus 4 d plus 1 is equal to 2 over 3. So further simplifying, we get this 2a plus 4d over after simplifying the denominator, we get 4a plus 4d plus 8 is equal to 2 over 3. Now we cross multiply it. We get 8a plus 8d plus 16. 8a plus 8d plus 16 is equal to 6a. Cross multiply 6a plus 12d. Now we can write it as 8a plus 8d plus 16 minus 6a minus 12d is equal to 0. Further simplifying, we get 2a minus 4d is equal to minus 16. Dividing each side by 2 because all the terms is the right and left are a multiple of 2. We can divide both sides by 2. We finally get a minus 2d is equal to minus 8. From here we can make a the subject a is equal to 2d minus 8. This is equation number 2. Now we will solve these two equations 1 and 2 simultaneously by substitution. Solving equation number 1 and 2, we will put the value of a in equation number 1. Equation number 1 is a plus d is equal to 13. Putting the value of a from equation number 2, this becomes 2d minus 8 plus d is equal to 13. So from here 3d is equal to 21 and d is equal to 7. Now the value of a we can get from equation number 2. Now putting the value of d in equation number 1, This becomes A is equal to 2 into D is 7 minus 8. We get A is equal to 6. So this is the value of A and this is the value of D.